Hello everyone, welcome to this video. In this video, I will show how to model 2D frame in Etabs and analyze it and compare to the hand calculation. So in this example, I use the example of RC Hibbeler textbook in the exercise of 4-38. So now let's get started into the Etabs program. Just open Etabs. And now we come to this page and select new model and use built-in setting. So we're gonna use metric metric SI unit, and for this is the material and region. For now, we don't need to use that yet. Anything is okay. Click OK. Now the previous video I choose blank, but now I want to choose the grid. You can choose either one. Okay, and again, if we choose the grid, it will automatic select the grid for us. However, it is not the grid that we want according to our problem. So we can edit it by right click in the model and choose add or modify grids. So okay, we will modify the vertical direction first. So there are five story that the program already set. But let's see our problem. We only have vertical direction. We have three level. The first one is at D point, the lowest point. I want to set this to be 0, and the point A is the second level. I will set this. Okay, this is about 2 meter different, and the last point is at BC, member BC. So 0, 2, and 4. For horizontal direction is 1.5 meter, 1.5 meter, 2 meter, and 1.5. So in the coordinate system, it will be 0 to 1.3 to 3.5. Oh, sorry, 0 to 1.5, and then 1.5 to 3.5, and then 3.5 to 5 meter. Now let's set. So I will delete the exceeding story, and this one also delete. Okay, now instead of story, I will name it level because, oh sorry, because it's a 2D, so I will name it to be level. Maybe it's more correct to the reality. Right? It should be level 0. You can name any name you wish. So and then come to the height. The elevation, it will automatically calculate. So what you have to do is just set the distance of each story. So from 0 to level 1 is 2 meter, and then from level 1 to level 2 is 4 meter. Automatic set the elevation for us. Now click OK, and then go to the horizontal direction. Click modify, and okay, let's check. Oh, okay. So it's gonna be, we set this point to be 0, 0, 1.3. Okay, again, 0, 1.3, 0, 1.5, then 1.5 plus 2, 3.5, and 3 plus 1.5 is 5. Okay, you can For 2D, you can choose either ZX or ZY direction. So let's say we choose only ZX. However, we need to set one grid for Y direction. Now everything look correct already. Let's click OK. And we will get our grid to be like this. It look weird. Okay, it look weird for this because you can see the plane here, it is in level 2 and plane Z. So we want to go to the side view, which is elevation view, and we choose the line grid for Y direction, Y plane or ZX plane. Okay, click OK. Here we go. It is our plane. And now we are ready to draw. To draw, we can click on the icon draw here, draw beam column, draw, and uh, we don't care what kind of section is this because it's the theoretical structure. So okay, to draw that, you can start any point. So in this case, I will start from this, like okay, like point A, B, C, D. Point A, click on it, and to point B, right click, to point C, and to point D. To escape, you can click escape. Or if you want to continue drawing, just do like right click. Okay, in this case, we finished drawing already. And the next is to set the support. So in this case, they say point A, C, D are pin connected. However, point A and D are external support, and point C is an internal support, internal joint. So they are a little bit different here. And point B is a fixed joint. Now, let's set the external joint first, joint A and D, and select two joints that are the same. Go aside, joint, restraints, and click pin support. If you it doesn't show pin here, but this is the fix that means it restrain every direction, every translation, moment, and uh, forces. And pin there is no moment, only forces in XYZ direction. So click apply. Okay, this is the external support. So for internal support, they say this is the hinge. In Etabs, if you draw like this, the joint it will be automatically fixed joint. So if you want to make it pin, you need to select the frame. Either in this case, this is a fix, so we don't need to do anything. But this point is a hinge, internal hinge or pin support. And you can either choose this frame and go release, go assign, frame, select release fixity. So uh, we just want to release this point. So let's get release the moment in the vertical direction and in the horizontal direction and torsion. Now let's try. Yeah, if it's correct, it will show the dot here. Sometimes it will be revised. For example, it might be end and start switch. So you can try and oh sorry, we need to select first. We can do the trial and error. See in this case. So we want to change to that point, just unclick them. Select again and go to delete in this end. Okay. On the other way, uh, we can also click this member and release the same way. So if you choose this member already, you don't have to do this because they share the same join. So now I just click OK. I think our model is complete. So the next step is to apply the load. Apply the load. I forgot where's the load. For 50 at 1.5 and 40 at 3.5. 15 kilonewton. Okay. So we want to apply the load to this point. So for the frame, we need to assign the load. We need to assign frame load. The previous video, I already show how to assign the joint load. So in this video, we will use the frame load and it's the point load. So choose point. And now, so the force, it can be also moment. So the force we will choose as gravity direction. And since we know the exact distance, we will not use relative. We will use absolute distance. So click absolute distance and we can name where the location we want to apply the load. So in this case, it's the location, the distance is 1.5 and kilonewton is 50 kilonewton. And the location by coordinate system is 3.5. You can check the model. Even not familiar, you can count from here, start from 0 and count from left to right based on your grid. So it's 3.5 and the load is 40. And that's it. Now click OK. See, it will show here. Now, for this side, it will be uniformly distributed load and in X direction. Now go assign again. Use frame load. Now, instead of point load, we change to distributed load. And this is the X direction. In the left to right is a positive. However, our load applied right to left. So we will need to apply the negative. We choose the global X direction, and we're gonna use, in this case, it's a uniform load, so we will use the relative distance. Relative distance, that means the program will automatically do the ratio of uniform load to our member. So we just need to apply the load. We just need to type the load here, and we need to make the negative side because it's in the negative direction. Now let's apply. See, it show here, so correct. Now click close. So, but when you apply here, this load disappear. How about when you want to see? It's easy. Just go to display and load assignment, join load or frame load. Okay, in this case, we apply load to the frame, so it's frame load. And click OK. See, we will show every type of load here. I think we almost done. However, one more thing is that in this analysis, in this example is theoretically example, so we don't need to consider about the cell weight of the member. So you just select all the member and go assign frame and property modifier and change the weight to be 0. So we don't consider about the cell weight. Click OK. Now everything is ready. Now let's run and save the file name to be just to frame 2D. Okay, done. And now this is the deform shape, but we want the internal force. So go display and show force and stress diagram, or you can press F7 for support and F8 for moment and shear diagram and Excel diagram. So I want to see moment and shear diagram. So moment 3 is about the member in the gravity direction, and moment 2 is the member in the vertical direction. So let's see the gravity first. Now click apply. Okay. It show everything now. That's great. I thought it will show separately, but it show everything. Okay, now let's go to check the moment and shear diagram. So in our result, okay, let's check this member. This member is did I use the unit correctly? I think something wrong again. So it's supposed to be the shear force should be 45 and the moment should be 180. So right here, there is something wrong. How about this member? Shear is 40 and moment is 54. I think there is something wrong here. But I think it's about the joint assignment. Again, to fix this, we can, in order to click to fix this, you need to unlock the model first. Okay, now let's go to check the release again. Click the member and go assign frame release fixity. Okay, let me try this again. Apply. And then close. One more step I was missing is because we need to set the end offset here, because when we draw the frame will have the overlap joint. So in Etabs, when it overlap, it will transfer the moment to each other. So in this case, we need to release. We need to set the frame to the end offset. Is the end offset. So to do that, just select all and go assign frame and end offset. Because this earlier it was we didn't set that. So the end offset is what is that? Okay, I'll show you. In this case, we didn't set anything. In this case, we don't set anything. So click OK. See, this is the side of an offset. So they will have the connection overlap here, which result in the moment effect. So let's see how it look. Okay, press F8 to see the result, and we use the moment 3 3. So you can see here, actually the point is here, but the moment diagram only show until here due to the moment uh, transfer by the overlap joint. In this case, our moment will not be exactly will not be fully transformed. So to do that, to make it fully transfer to each member, we need to set the end offset to be 0. To do that, just select all the frame, go assign frame, and then this one end length offset. So when we need to click the define length. So in this case, we want 100% connected transform. So each member they will connect from 0 to 0, and the coordinate 0 0 of each frame. Now click OK. Okay, now let's run again. Okay, now see to see the result of moment, press F8 and we click moment in 3D, moment 3 apply. Okay, you can see now the moment diagram will start from 0 and until 0, and then continue to the next frame 0 in the point 0 until the end. So now let's check. Remember AB, the shear force is 45 and maximum moment is 180. So go to verify our result. Okay, here shear force member AB 45 and moment is negative 180. So it's correct. And for other member is I think should be correct. Let's check this member. Maximum shear 83, maximum moment 180. Maximum shear 83, maximum moment 180. I think is correct. So the last one should be also correct. Now this one, maximum shear 45 and maximum moment is 67.5. This one, yes, it's correct. Okay, so our result finally correct. So for frame, you should set the condition of joint correctly in order to run it smoothly. So I hope you get something from this video and hope to see you in another video. Thank you.